Hey guys, welcome back to another video. I'm Roland and I'm your tutor from thinkbrainwave.com. In this video we will be tackling trigonometric functions, and in particular we'll be discussing the sine function. In previous videos in a different video series we looked at how sine and cos were related, but in this particular function we'll start discussing functions from a trigonometric point of view and how to draw them, the shifts, their movements, the amplitude, the frequencies, etc. It's all going to be a little bit more in-depth. It's not very difficult, so make sure to stay tuned, relax and enjoy. So we'll be doing a sine function in the form of y is equal to sine theta. This is your general basic function. It starts off at sine 0. Sine 0 is equal to 0. At sine 90, the value would be 1. And at sine 180 you go back down to 0. So how do you start plotting the sine theta? A sine graph needs a set of axes and needs pretty much a table where you'll calculate predefined values ranging from 0 all the way to 360, and that'll be in the positive range. One can also go from negative 360 all the way to the positive 0. But in this case, we will be focusing from the values between 0 degrees, including 0, and all the way to 360, and including 360. First off, it's very simple. We need to draw a table. As mentioned previously, we need to make sure that we calculate all the relevant values and then plot them on a Cartesian plane. If you don't understand how a Cartesian plane works, please make sure to go check one of the videos in the trigonometry video set. You'll learn a little bit more about how the cast system works, where cos is the bottom right, and all values of cos are positive. The all values are the top right, which is your first quadrant. Top right is first, second is top left, third is bottom left, and fourth is bottom right. So with that said, let's move on. We start off our table by saying that theta is at the top and sine theta is underneath it. You can almost see sine theta as the y value, as you're used to with normal functions, and theta would be your x value. So that's what I've written above. We say theta is like your x value, and sine theta would be, your function of x, which we have learned is actually the same as saying y. So I've just written that over here, function of x. I've drawn a table up for you, and now let's do our first step. We substitute the relevant values for the theta value, starting at 0 degrees, into the sine equation. So pull out your calculator and start knocking those numbers in. So you say sine of 0, you then have sine of 30, you have sine of 60, sine of 90, 120, 150, and all the way through to 360 degrees. I'm quickly just filling these out. If you want to slow down the video, just press pause and you can calculate them yourself, just to make sure that everything is correct. But you'll notice a bit of a pattern starting to appear. At 0 degrees, sine theta is 0. We know that from special angles, the particular triangles where you start with an equilateral triangle with 60 degrees in every angle, we cut that in half, we get a 30 degree, 60 degree, and 90 degree triangle. We also know that sine of 30 is a half from those special angles. It goes 0, 0.5, 0.87, 1, back down to 0.87, 0.5, 0, and then you start going the same sort of structure into the negatives. You have negative 0.5, negative 0.87, minus 1, minus 0.87, minus 0.5, and 0. So you start and finish at the same values. Plot the points with a smooth curve for step 2. It's quite simple. You now have your basically x and your y values, which you can now plot. But in this case, we're doing trigonometry. So we start with thetas and sine thetas, f of x and f of thetas. So if you're going to draw this out, easiest way to do it is to draw that sort of T shape that lies on the side. You then draw your first line in the middle of the sort of x-axis. You then draw your end line and 2 lines in between those lines. So you have your 180, your 360. Between them, you'll have your 90 and 270. You then label your axes, you label your origin, and if you'd like, you can label your points in between. As you can see, I almost put a 45 degree, but we will not be using 45. We're using 30, 60, 90, 120, etc., etc. Here we have it. It's all been done for us. I just thought let's jump ahead. If these videos are too fast for you, you feel free to pause. Otherwise, restart the video or just check out the notes that we have at thinkbrainwave.com. We host everything from videos to notes and including tests, so you can test yourself pre-exams or pre-tests, and make sure that you understand the set of knowledge very well. Don't forget that you also need to label your y-axis. Your y-axis in this case will go up to a maximum of +1 and a minimum of -1. Also notice that we are moving in increments of 30 degrees. So we start at 0, we go to 30, then 60, 90, etc. as previously explained. So if we're going to draw our points, we start off with the 90s, the 180, 270, and 360. Those are generally the easiest, and they give you the general shape of the curve. So later on in this sort of section, you'll see there'll start being some shifts and some squeezing, etc., etc. You don't need to know about it just yet, but you will learn about it in the future. So it's very important that you understand your basics now. And if you don't, please watch these videos time and time again. Make sure that you're doing your points correctly, like you saw that point was incorrectly placed. Erase that point. Also make sure to do your point correctly the first time so you don't have to have too many errors. Teachers do not like seeing errors on a piece of paper, so always go into trigonometry with a strategy. This has always been mentioned many times in previous videos. It's especially important to have a strategy with trig because you can take 5 steps to 10 steps to do something that could easily just take you 2 to 3 steps, and you can save yourself 50 to 100% of your time. You know, if you're taking double the time to do something, that's pretty much doing 100% extra work. So take an extra few seconds, 10 to 20 seconds, analyze your question, analyze what you're going to do, and then get into it. Don't just jump right in and go, oh goodness, I made a mistake and have to start all over again. So like you saw over there, I mentioned that that would be an x value. I then changed it to a theta because that's a very big mistake that many students make. They'll write an x there instead of the theta because they're used to doing an x and y axis. So it's very important that you actually change that y as well to an f of theta because it's a function that's relative to the theta value. Now we know our domain is between 0 and 360 degrees because it's starting at 0 and moving to 360. However, our range is between -1 and including these two values, so it's between -1 and 1. Now we use square brackets once again to emphasize the fact that we're actually including these values in our domain and range. Never include infinity or negative infinity. Just a couple of reminder points. Right, now let's look at our x-intercepts. These are the kind of things we need to mention when drawing a graph in trigonometric functions. So you are intercepting the x-axis at 0, 0. You then go to point 180 degrees and 0 degrees. And then you get to 360 degrees at 0. Notice it's not a range or a domain, so you always use round brackets. Your y-intercept is quite simply 0, 0. You're only going through the origin. However, just make sure that this is not always going to be the same because when you do start shifting your function, it can shift upwards, it can shift leftwards, it can stretch. So make sure not to just write 0, 0 every single time because this is the only video that you've watched. Make sure to watch the coming videos because we will be explaining how everything changes. It's just like normal functions like a parabola or a hyperbola or a cubic. You may not have done cubics yet, most probably by grade 10, but you've done exponential graphs. These graphs shift up and down, left and right, and it makes a big difference for you to know that. Now, if you look at your maximum turning point at 90 degrees, your highest y value is 1, and your minimum turning point would be at 270 and -1. I'm just labeling this in the correct colors so that you can follow it and track it. I did the maximum in red and I've done the minimum in purple. It's very easy to read across. There's no shifts, so it is 270 degrees and -1. Alright, that's it for this video. I hope you enjoyed, and as always, easy game.